Assalamualaikum and greetings everyone. Today's topic is on Stokes' theorem. Stokes' theorem involves a vector field in XYZ space and an open surface sigma that spreads across this field. So according to the Stokes' theorem, f dot dr integrate over closed curve C is equal to curl of f dot unit normal vector n integrate over open surface sigma. Okay, so in this case, n here is the unit normal vector to the open surface sigma, and closed curve C is the boundary to the open surface sigma. So here we have 1, 2, 3 examples of open surface. So if this is your open surface, then the red curve here would be the closed curve, and here we have a plane. So for this plane, the red curve there, the 4 straight line would be the closed curve, and here we have a paraboloid, an open paraboloid. So the circle here, the red circle, would be the closed curve to the open surface. Okay, now the orientation of the closed curve C and the unit normal vector n obeys the right hand rule. So here the thumb here represent the normal vector. Your thumb, your right hand thumb would be the normal vector to the surface, and your fingers here would be the orientation of the closed curve. So in this case, the orientation would be anti-clockwise direction. So your fingers represent the orientation of your closed curve, and your thumb represent the normal vector to the open surface. So now if you look at our open surface again, so let's say your normal vector to the open surface here is pointing upwards like so. Then using your right hand rule, then you can see that the orientation of the closed curve here would be anti-clockwise direction. Okay. Now if you look at the second open surface, this plane here, if your normal vector is pointing upwards like so, okay, then again using your right hand rule, the orientation of the closed curve would be anti-clockwise as well. Okay, now if you look at the third open surface, the open paraboloid, if your normal vector is pointing, let's say we choose it to be pointing downwards, okay, then using your right hand rule, the orientation of the closed curve would be clockwise direction. Okay, so the relationship between the closed curve and the direction of the normal vector obeys the right hand rule. So if the direction of the closed curve is given, then you can determine the normal vector to the open surface, or vice versa. If the normal vector to the open surface is given, then you will be able to find or determine the orientation of your closed curve. Is it clockwise or anti-clockwise? Okay, now here's a few examples. So let's say you have a cone. So here we have a cone, open cone. So here we have an open cone. Okay, so the boundary to that open cone would be this circle. Okay, so we have that circle. So that would be the the closed curve, which is the boundary to the open surface. As you can see, the closed curve, the shape of the closed curve would be the same if your open surface is this plane. So if this is the open surface sigma, then you can see that we have the same closed curve, which is also a circle. Okay, or in this example, the next example, let's say this is your open surface sigma, then the boundary to that open surface is also a circle. Okay, sometimes it's useful to have this information. Okay, so if you want to find del cross f dot normal vector to the open surface sigma, you can see that all the open surfaces that we have here, the cone, the plane, and the paraboloid, they all have the same closed curve. So that would be f dot dr. So you can, if you want to use closed curve here, f dot dr, it would be the same if your open surface is either a cone, a plane, or a paraboloid, because you can see that they all have the same closed curve, which is a circle. Okay. Now, how to evaluate? Okay, let me explain how to evaluate Stokes theorem. As you know before, that this should be gradient of phi, not normal vector. So that is just del phi. So the gradient of phi is the normal vector. Normal vector divided by its magnitude is the unit normal vector, and ds is magnitude of normal vector dA. So how to evaluate Stokes theorem is, okay, let's say you want f dot dr integrate over curve C. So according to the Stokes theorem, this is equal to curl of f dot with a unit normal vector integrate over surface sigma. So how to evaluate that is we're gonna project our surface sigma here onto a region which is either on an xy plane, xz plane, or yz plane. Okay, over project this onto a region, and then unit normal vector ds will be replaced by normal vector dA. So the technique would be how to solve this is you find del cross f first, and then find the correct normal vector, dot the two vectors, and then integrate over region R, which is the projection of your open surface sigma. Okay, for examples, I'm gonna show that in the next video. Thank you.